Multiset theorem. Actually, here we will use the idea of multiset for solving certain kind of combinatorics problem. Based on this idea, problem came in INMO 2005. What is a set? Set is a well-defined collection. Set is a well-defined collection of objects. There are some rules in set which I'll call Cardinal Rules. According to this, if there are repetitions, suppose I am considering the set made up of A, B, A, then I would simply write it as A, comma B. Repetitions are not allowed in set. Means the element should be distinct. When this rule is violated, elements should be distinct. When it is violated, the resulting set would look like A, comma B. This is the concept of multiset. Where all the elements are not distinct, this kind of set are known as multiset. Here in combinatorics, we extend the idea of multiset into a variety of combinatorial problems. We have seen permutations with repetition. Now here comes choosing with repetition, combinations with repetition. Suppose a question is there like that. We are having 6 brands, 6 brands of chocolates, and we want to select 4 chocolates from them. It is assumed that we can choose the same brand repeatedly. So suppose the brands be like B1, B2, B3, B4, B5, B6. In this situation, now let me choose the chocolate. Suppose I am choosing 2 chocolates from brand 1, B1, B1. 2 chocolates from brand, 1 chocolate from brand 4. 1 chocolates from brand 4. And 1 from brand 6. Brand 6. Now there are some empty brands. Let me denote the brands by X, X, chocolates by X and X, which has been selected from them. Now there are some empty brands from where we are not selecting any kind of chocolates. Let's denote the brands by boxes. So how will our box look like? This would be the arrangement of box. Now here we do not need to give any kind of vertices, because here without any kind of vertices also we are demarcating the 6 positions where they can be arranged. So we have chosen 2 from brand 1. So the first X comes from brand 1. And then directly from brand 4. Brand 4. In between we are leaving 3 vertices, vertical lines which are denoting box. 1 from B4, leaving 2 lines. So now this is also choose from brand 1 and this is also choose from brand 1. This and this. So there is no gap between brand 1. So the line should not be placed here. Line should be placed here. One, two, three. This is our brand 4's chocolate. two gaps are there, two lines are there, demarcating the boxes. So now how many positions we are getting? We are getting 1, 2, 3, 4, 5, 6, 7, 8, 9. And we are choosing 4. 9 choose 4. This is our answer. Some says that the answer is 6 choose 4. This is wrong, because here repetition is allowed. Multiset is possible. That's why it's sometimes known as multiset theorem. Some says that distribution of different balls of different brands into like that, boxes like that, different boxes, balls in boxes. That's the simple logic. So if we are having 6, 4, this can also be written as 6 plus 4 minus 1, choose 4. And this is always true. For N and R, for N brands and R chocolates, this can be written as N plus R minus 1, choose 4. This is the most simple derivation of the formula using mathematical induction, hence proved using mathematical induction. Now, let's come to the point. Before coming to the main point, let's discuss one more question. How many distributions are possible of 5 indistinguishable? How many distributions are possible of 5 non-distinct objects into 7 distinct boxes? It can easily be solved. Let me solve it. 5 non-distinct objects, 4 candies are non-distinct, 7 brands, let it be candies. Let it be candies, let it be brands. Done only. This stands for R, this stands for N. Is it done? N plus R minus 1, choose R. That would be 7 plus 5 minus 1, definitely. 11, choose 5. That's all answer in our hand. Answer in the hand. It's done. All possible 6-digit number in which the digits occur in non-increasing order. Non-increasing order. From left to right. Non-increasing, it's decreasing order. In other words, decreasing order. Are written as a sequence in increasing order. Like 8, 7, 7, 5, 0. 8, 7, 7, 4, 0, we can say. Or the next term would be 4, 3. So on. Are written in a sequence in increasing order. So it's decreasing order. They have mentioned that it has been written in increasing order. 8, 7, 7, 4, 3. 8, 7, 7, 5, 0. So on. Increasing order. Find the 2005th term in this sequence. And this was the question asked in INMO 2005. For combination, we know that arrangement doesn't matters. That is the most important key for combination. Now, arrangement doesn't matter. And suppose we want a unique arrangement, then also we can use unique arrangement. Then also we can use the concept of combination. Suppose two unique arrangements with combination of three different objects, then nothing else. The combination will be multiplied into 2. Now here is only one unique possibility with every of this number. Suppose we have been asked to create a such kind of digit who is following all the criteria, then how many unique ways we can form by some fixed number of digits. Suppose we have been asked to form a digit with 8, 6, 6, 3 and 2. We have been asked to form a digit with them. Then this is the only possible way of writing them: 8, 6, 6, 3, 2. So we just need to choose. From our available options, because arrangement is here unique. Or we can say arrangement doesn't matter. But now in this case, we have learned combination without repetition. Here, this is the case of combination with repetition, or multiset theorem. So we will use that formula to come to the conclusion. For this, we need to list all the terms in a systematic fashion. Suppose the number, since it has been mentioned that they start with a increasing order, can be written as, so definitely the first number would start with 1 at a certain place. 1. It will be like something 1, 2, 3, not 1, 2, 3. 1, 9, 8, 7, 6. It's a 6-digit number. 5. So it has to start from 1. It has to start from 1 at the first place. It has to start from 1. We can say starting digit or fixed digit, or this is fixed also, this 1 is fixed in its position 1. Now how many options we are having? Now in case of 1, what are the digits that we can use? We cannot use 1, 9 as the example. We cannot use. Why? Because 9 is greater than 1 and it is not possible with the given criteria. So we can use only 1 and 0. The digits that we can use, digits other than the fixed digits. Digits other than the fixed one. Here we are writing this. Digits other than the fixed one. 1 and 0. It's given here. The condition is given that all possible 6-digit number in which the digits occur in non-increasing order. It can be 1, 1. It cannot be 1, 9. Here it is increasing order. So what are the two possibilities? It can be either equals to 1 or lesser than 1. If we are having n, then it has to be lesser than equals to n. That is the simple logic. So lesser than equals to n, lesser than equals to 1, we have only 0 and 1 as the available option. 1 and 0. So how many options we are having? N and R. Our formula was n plus r minus 1, choose r. For repetition allowed, n is 2. and it's a 6-digit number, so we are having 5 spaces left. R is 5. We have to compute the value. This comes 6 choose 5 equals to 6. Now here we will record the cumulative sum or frequency, whatever it is. 6. Some would think that it is 10. I just said that here are 5 available spaces. It was indicating the 5 available spaces. 5 available spaces. That's why it's 5 here. That's why it's 5 here, isn't it? And we have repetition allowed. Now we have to choose from this 1 and 0, 2 options we are having. Now suppose the number beginning with 2. The number beginning with 2. Now we are having 2, 1 and 0. Fine, 3 options. R is what? R is 5 only. For this case also, it's not changed here. Then what will happen simply? Here we will get 7 choose 5. That is 21. Cumulative frequency comes to be 27. Here 3. Definitely we'll have 4 options here. 4 options. It's increasing, so we can ignore this part. We can just go with this pattern 2, 3, 4, 5, 6. We just fill it up. Now R can not always be seen because we have to think for the cumulative frequency also. So here it will be simply, here it's also 5. Because cumulative frequency is not going to increase suddenly in that fashion. Then we have 8 choose 5. This comes to be 56. So in a similar fashion, we need to fill these empty spaces. It would be our task. Let's do it. Let's do it. Fill up the blanks. Fill up the blanks. Tell me the cumulative frequency for 5. We want the cumulative frequency for 5. Okay, I am filling them. This is 83. How comes this 83? That we have to calculate ourselves. That we have to calculate ourselves. How comes 83? 83, 209, 461. This would be 9 choose 5. This would be 10 choose 5. Now these are the number of digits that we have preceded. Now let's go for the next one. Since we want the 2005 and we are here with only 461, we want 2005. Our target is much larger. Now here let's go for 6. It would be 11 choose 5 here. 11 choose 5 here, which will give us cumulative frequency 923. Now comes 7. It will be 12 choose 5 here, which we have to add with this to get 1967. Now we are closer. We can see the gap has increased to 1000, and if we just go for the logic of 8, it would cross 2500. Definitely. Now we need to slow our journey. Now we need to slow. How do you slow down? It's not 1967. It's not 1967. It is 1715. So we can see that the gap has increased enormously. If we just go for 8 with our earlier principle, we will definitely. So let's use trial and error method. Let us assume that the number lies between some 2. This is the possible one. Let us assume like that. Now, how many possibilities we are considering here? How many possibilities we are here? Now, this space is important. 5. From 0 to 5, we have 0, 1, 2, 3, 4, 5, so on. 1, 2, 3, 4, 5. We have not pre-filled any space. We have not pre-filled any space. So it will be simply 6, choose 5. This will be 6, choose 5. 6, choose 5. So let's assume that we are considering the digits. Let's assume that we are considering the digits. Up to this, we have 5, 5, 5. So we have 0, 1, 2, 3, 4, 5. These kind of combinations are also possible. These kinds of arrangements are also possible, we can see. So we have 0, 1, 2, 3, 4, 5. These were the digits other than the fixed parts which have given us this result. Yeah. So the value of n will be definitely 6, because we are starting with 8. 8 is the only fixed digit. We are not considering it. We are just showing that 8 is the fixed part. These are the numbers. Then 6, choose 5. What's the value of 6, choose 5? We have to go for this. 6, choose 5. No, not 6, choose 5. How this would be 6, choose 5? That's again our formula. N plus R minus 1, 10, choose 3. Sorry, 10, choose 5. 10, choose 5. This is simply 252. If we add this, we would get 1967. So we can see that we are just 38 terms behind 2005. Most probably we are just 38 terms behind 2075. 38 times behind we are. Now here comes our knowledge. That what should we select? How should we approximate this? Let us now consider to 8, 6, 0, 0, 0, 0. Now they must need to be in decreasing order. What was the question? 8, 7, 7, in which the digits occur is non-increasing order. The digits occur in non-increasing. So yes, this is our possibility 8, 6. We cannot choose 8, 6, 0, 0, 0 because our digits available are 8. In this case, we are choosing the 6 at least for once only. That means what? 0, 1, 2, 3, 4, 5, 6 we are choosing. Now 0, 1, 2, 3, 4, 5, 6, the maximum can be 8, 6, 6, 6, 6, 6. Why 8, 6 or how 8, 6, 0, 0, 0 will be the maximum in this case? So our maximum in this case it's 8, 6, 6, 6, 6, 6 like that. Again in the most similar fashion, if we just calculate the possibilities, what would be our possibilities? After this very term, what would be our next possibility? Is it 8000? No, it's not. It's not 8000. After this term, what is our possibility? My question is there. We go for 8, 6, then 0, 0, 0, 0. This is our possibility. So 8, 6 is the fixed part we are getting. 6, 6, 6, 6. Isn't it? So here, our unfixed part is only 4. Unfixed part is only 4. And available options are 0, 1, 2, 3, 4, 5, 6, 7. Is it so? Yeah, 7. So if we calculate this, n plus r minus 1, this will be 10. Choose 4. Now what's the value of 10 choose 4? We have to find out. I guess this value is 210 and it will exceed our 2005's target because we need only 38. So 666 is not a possibility. Let's reduce it. Let's reduce it to 86. We're not considering 6 now. 85 is already considered. What can we consider? Now let's consider 86333. 8633333. Here in this case what we will get, we have to think. Here we are having available options because this 86 part is fixed. So now we have seen that thinking about 866, this is not possible. But the next term is definitely 86. This is definitely 86 because 85 is already considered. The next term needs to be 866. All the term possibilities have been considered. So now let's take 86. Let's lower it to 2222 like that. 86222 like that. Can we consider it? 86000. 0 2 8 6 2 2 2 2. Then we are having three options, 0 1 2, three options, and we can arrange them in four positions. Then 3 plus 4 7 6, 3 plus 4 minus 1, choose 4. We have to calculate what's the value of this. This comes to be 15. This comes to be 15. We need 38, yeah? We need 38. So let's now consider little bit more higher. 8 6 3 3 3 3. Why we're taking here 4? Because two digits are fixed here. 8 6. These are the unfixed number. See, every time we are changing this, these are unfixed number. So 4 3s are there. 4 3s are there. Here this option is only changing. 4 choose 4. No, 7 choose 4. This is what? This is coming to be 35. Then adding 35 to this, we would get the 2000 tooth term. Great. We have our 2000 tooth term to be 863333. This is the 2000 tooth term. We can find the 2003 term according to the rule provided. 86 increasing order 864 0 0 0 0, one extra 0. Then the next term 864 3. Why 3? 1 is also there. 1 0 0. 864 1 1 0. This is 2004 and this is 2005. INMO's one problem solved. INMO, not INMO. INMO and INMO 2005 done.